Hi everybody, today we are going to keep talking about solving multivariable linear systems. Alright, so when you are solving a system of three linear equations, so there's a number of different outcomes you can get. So you can have exactly one solution, and what it looks like is you have three planes that are crossing at exactly one finite point. However, there's a lot of different ways you can end up with no solution. So you can see that there are cases in which two of the planes do cross. They interact with each other, but the idea is that they're not all crossing at the same point, which is why that there's no solution for all three. So you can see here even two of the planes are crossing the same other plane, but not at the same point, or maybe they just never cross at all. And then the last outcome could be infinite solution. So the point, or all three planes are crossing, and it kind of makes a line. So you have to find a way to describe the relationship between the three variables. All right, so let's give this a try. So we're still going to go about solving each of these problems using our same method. We're going to try to create a system of two variables. So when you have equations that are missing variables, it's actually a good thing. It means that they've already done part of it for us. So let's say we want to keep y and z. So let's try to create a system with just y and z. So I'm going to rewrite this one because we already have a system of two variables, which means I need to eliminate x again. So I can do that by adding my first and third equations. And so what we end up with is 3y minus 3z equals 0. So I'm going to write that up here. So you can see that in this system of two variables that we've created, it actually makes exactly the same graph, which is a case where we have infinite solutions. So when we have infinite solutions, we have to find a way to relate the x, y, and z values. There is going to be some type of relationship between them. So here you're going to either pick one of your two variables from your system of two. So I'm either going to pick y or z, and I'm going to let that variable equal a. So let's just say let y equal a. Well, if y equals a, and I substitute that right here, I can see that, well, z is also a, because y is actually equal to z. And then I'm going to take those two, and I'm going to substitute it into my third equation, which is right here, because if I substitute my y, I can find x. So I have negative x plus 2 times a, which is what we're calling y, equals 1. So we have x equals 2a minus 1. So now we've written all three of our variables in terms of a. So y is equal to a, z is equal to a, and x equals 2a minus 1. And now we just have to write it as an ordered triple. So 2a minus 1, a, and a. So this is just kind of giving us a template that we could use to list possible outcomes. So while there are an infinite amount of outcomes, we know that the y and z values will always be the same, and the x value will always be twice that minus 1. So we can use this, and we could just plug in different a values, and you can get possible solutions. All right, so go ahead and pause the video and give this problem a try. All right, so when I solved this problem, I chose to eliminate my x's twice. So when I did that, I got these two equations, which I noticed are opposites. They actually cancel each other out completely, meaning that it's infinite solutions. So at that point, I decided to let z equal a. The reason I picked that is because if I set z equal to a, it's really easy to solve for y. If you set y equal to a, it is possible to solve for z, except you're going to have like some big ugly fractions, and it's going to be a nightmare to find x. So try to pick the one that makes it easier to do. So here, I think the easy way to go is by setting z equal to a, which means that y is 15a minus 13, so I use that and solve. And then I plugged those two values into my first equation, so I substituted y and I substituted z, and you get x equals negative 23a plus 22. So this is not the only way you can write this answer, but the relationship between the three variables should always be the same. Okay, now we're going to talk about what are called non-square systems. So you can see here that we have two equations with three variables, but if we only have two equations, we know that we're not going to be able to solve for a finite point. However, we are going to see if there is some way where we can give a relationship between the three variables. So when you have a problem like this, the first thing you're always going to do is just pick one variable and eliminate it. So eliminate one variable. So I can see that in this case it's going to be easiest to eliminate our z. So let's just add the two equations together, giving us 3x minus 3y equals 3, which I'll just write as x minus y equals 1. So now I have an equation with one variable. So our second step is going to be to solve for one variable. So we can either solve for x or y. I'll solve for y. I'll say y equals x minus 1. So this is just about as much as we can do to solve for y at this point. There's no way we can solve for an exact number. So now once we have solved for one of our variables, you're going to go back and back substitute. We're going to plug that into one of our original equations. So sub into original equation. And we're going to see what we have to work with. So I'll substitute it into our first equation. So we get x minus 2 times y, which is x minus 1, plus z equals 2. So if you distribute and then here you start solving for x, you actually get x equals z. So from here, we're going to pick one of our variables. Doesn't matter if it's x or z, and we're going to set it equal to a. So we'll say let x equals a, so that means that z will also equal a, and then we can substitute that. Let's substitute it right here to find y. So we know that y equals a minus 1. So we have a minus 1, a. All right, so go ahead and pause the video and give this problem a try. All right, so here I notice that we already have a system of two right here, so take advantage of that, and I can easily solve for z. And then once I've solved for z, I go back and plug it into the first equation and solve for y. From here, we can say let x equal a, which means that z is 4a and y is 17a minus 3. So that's the relationship between the three. All right, the last thing we're going to do is model quadratic equations. So we know that the standard form of a quadratic equation is ax squared plus bx plus c. So we can actually find that equation if we know at least 3 points. So if we're given 3 points, we're essentially given 3 x, y values, which we can substitute to create 3 equations, which we can then use to solve our system of 3 variables. So let's substitute the point -1, 3. That would give us 3 equals a times -1 squared plus b times -1 plus c. And I have 1 equals a times 1 squared plus b times 1 plus c. And then 6 equals a times 2 squared plus b times 2 plus c. So that essentially gives us a minus b plus c equals 3. A plus b plus c equals 1, and 4a plus 2b plus c equals 6. So now we just have a system of 3 variables. So I'm going to solve this system by eliminating the b's. I'm going to eliminate b's twice. So I use the first and second, and I get 2a plus 2c equals 4. So that's essentially going to give us the equation a plus c equals 2. I'm just going to divide by 2 just to make our life a little easier. And then I'm going to use, how about the first and third equations? I'm going to multiply the first one by 2. And then 4a plus 2b plus c equals 6. And we get 6a plus 3c equals 12. So I'm going to divide both sides by 3. So we get 2a plus c equals 4. And now we have our system of 2. So I'm going to solve this one using substitution. So we can say that A, or let's say C equals 2 minus A, and then we could substitute it into the second one. So 2A plus 2 minus A equals 4. So if we combine like terms here, we get A equals 2, and then we could substitute that right in here. So we get C equals 2 minus 2, which is 0, and then you can take those and substitute it into any of your original 3. So I'll say 2 minus B plus 0 equals 3. So B is going to be negative 1. And of course, we just need to write that as a quadratic equation. So we get y equals 2x squared minus x. All right, last problem. Go ahead and pause the video and give it a try. All right, let's check our work. So we have our 3 equations. So you'll notice that we actually have the C value. We know that C is equal to 1, but you still need to create a second equation with 2 variables, and make sure that C is one of those variables. So you can see that I eliminated the B values, and then I could substitute C equals 1 to solve for A, and substitute A and C to solve for B. So you should get negative 2x squared plus 3x plus 1. All right, that's all for today. Thank you for watching.